Hello, welcome to my channel Mahadev Academy of Science. Within this video, we are going to discuss the concept of Gibbs free energy. Now here, if you see, you must be knowing what is a system. Anything which is under observation is known as system. Let us suppose you are going to have this as a system, and within the system we are going to have some amount of energy. Okay, so let us suppose this is going to represent the total energy. This can be represented by E or U. Okay, so this is going to represent the total energy. Now out of this total energy, only some part of the energy of the system, it is going to carry out some useful work. Now here keep in mind, this part of the energy which can carry out useful work, okay, that is known as Gibbs free energy. So here you can define Gibbs free energy as the part of energy of system which can carry out useful work is known as Gibbs free energy. So here hopefully you have understood that within the system you are going to have some total energy, but out of this total energy only some part of the energy can carry out useful work, and this energy is known as Gibbs free energy. Now you must be knowing what is first law of thermodynamics. As per first law of thermodynamics, energy can neither be created, energy can neither be created nor it can be destroyed, but it can be transformed from one form to another form. So this is the first law of thermodynamics. Here what you are going to see, energy can neither be created nor it can be destroyed. So here you can remember that the energy of the entire universe, it is going to be constant. Something you can't create, something you can't destroy. And here what you are going to see, energy can be transformed from one form to another form. Okay, so you must be knowing different forms of energy. So here keep in mind, energy can be transformed from one form to another form. Now here if you see the second law of thermodynamics, as per second law of thermodynamics, okay, so here the statement is entropy of universe. Okay, entropy of universe is going to increase in spontaneous process. Now here what are these spontaneous process? The process which do not require input of external energy. Okay, so if you see the statement of second law of thermodynamics, it is the entropy of the universe, okay, not the system. Now hopefully you know what is entropy. Entropy is degree of randomness, degree of randomness. Okay, now try to see here. if you are going to have something solid, okay, so within the solid, the molecules, they are going to have less degree of randomness, okay, they are going to have fixed position. While if you have this liquid, okay, within the liquid, the molecules, okay, they are moving fastly. Here you are going to have more entropy. And if you are going to have this, let's suppose gaseous state, okay, in the gas state, okay, the molecules, they are moving more randomly. Here you are going to have higher entropy, highest, okay. So here in the solid, you are going to have less entropy, while if you see in the liquid state, you are going to have more entropy, and here in the gaseous state, you are going to have the highest entropy. Okay, so hopefully it is clear to you what is first law of thermodynamics and what is second law of thermodynamics. Now here, if you see both of these laws, they are not going to tell us what is the direction of any reaction. Okay, now you must be knowing some of the reaction, they are going to occur like this way. Let's suppose A is going to react with B, and what we are going to see, we are going to see the formation of C and D. Okay, A and B both are reactant, and what we are going to see, the formation of product C and D. Yes, this reaction is also occurring in the backward. Okay, so here C and D, they can also react, and what you are going to see, you are going to see the formation of B and A. Now, if we want to calculate in which direction this reaction is going to proceed, this can be calculated by the concept of Gibbs free energy. Now, here keep in mind, if the value of change in Gibbs free energy, so delta G, here it is change in Gibbs free energy, okay, if this value, it is 0, okay, if this value you calculate and it comes out 0, then keep in mind the reaction, this reaction is at equilibrium. Okay, so when any reaction is at equilibrium, keep in mind change in Gibbs free energy will be 0. Now try to see here what that means. Okay, so here in case of equilibrium, what we are going to see, rate of forward reaction is equal to rate of reverse reaction. Okay, so rate of forward reaction means the rate at which A and B both are going to react is going to be the same with the rate C and D is going to react. Okay, so let's suppose A and B, they are going to react and they are going to form 5. Okay, this C and D, same as C and D, they will react, and what you are going to in the backward, you are going to same the same A and B, they are being formed. Okay, same rate. Okay, keep in mind this is not the concentration. At equilibrium, the concentration of reactant is not equal to concentration of the product. Okay, so hopefully you are going to keep these points in your mind. Now, here, if the value of delta G is equal to positive, okay, keep in mind such reactions, they are endergonic reactions. Okay, means these reactions, they require input of energy. Okay, so here what is going to happen, the reactant, they are going to have less energy, while your product is going to have more energy. So here what you have to supply, you have to supply the energy. In that situation, this reaction will proceed, otherwise it will not proceed on its own. Here you see delta G is equal to positive in the case of endergonic reaction. Okay, in endergonic reactions, what you are going to see, you are going to see no release of energy. Okay, and here what you are going to see, such type of reactions, they are non-spontaneous. Okay, now here if you see another situation, okay, if you calculate and the value of delta G, it comes out negative. Keep in mind here, if the value of delta G is negative in such reaction, okay, what you are going to see, you are going to see release of energy, and such reactions, they are known as exergonic reaction. And these exergonic reactions, they are actually spontaneous reactions. Hopefully it is clear to you which type of reactions are going to occur on its own, in which you are going to have the value of delta G negative. Okay, now let us suppose A is going to react with B. Okay, and what you are going to see, C and D, formation of C and D. And here if you calculate the value of delta G, which comes out positive, then this reaction will not proceed in the forward direction. Okay, and let's suppose you are going to have X plus Y, it is going to react, and you are going to see the formation of, let's suppose, A plus B, you can take anything. Okay, and if the value comes out delta G negative, okay, then this reaction is going to proceed in the forward direction. Okay, so here this concept of Gibbs free energy, it is going to tell you the direction, okay, in which direction any reaction is going to proceed. Now here I just want to tell you that within the cell, okay, you are going to have reactions, okay, like glucose, okay, it is going to interact with inorganic phosphate. Okay, and what you are going to see, you are going to see the formation of glucose 6 phosphate. Now this reaction, it is being carried out by the enzyme hexokinase. Okay, hopefully you remember the first step of glycolysis. So glucose is going to react with inorganic phosphate, and what we are going to see, the formation of glucose 6 phosphate. Now here if you see the delta G prime naught O, okay, standard change in Gibbs free energy at cellular condition for this reaction is 13.8 kilojoule per mole. Okay, now here if you see the value is positive. Now here if you see this reaction, it can't occur spontaneously within the cell. Okay, why? The value is positive. Now how this reaction is going to proceed, how this is going to occur within the cell, when this reaction is being coupled with another reaction. So another reaction is ATP, it will be hydrolyzed, and what we are going to see, ADP plus PI. Okay, and here what you are going to see, delta G prime naught O, it is minus 30.5 kilojoule per mole. So here let's suppose you are going to have this one as 1 and this one as 2. Now keep in mind, when this reaction is non-spontaneous and this is spontaneous, okay, when both are coupled, okay, both are coupled, then this reaction is going to occur, overall reaction is going to occur. And if you calculate the change in Gibbs free energy for the overall reaction, it will be delta G is equal to delta G, okay, prime naught O for 1 plus delta G prime naught O for the second. And if you calculate, it will come out 13.8 minus 30.5, and if you solve this, it will come out minus 16.7 kilojoule per mole. So here if you calculate the overall, okay, change in Gibbs free energy for this reaction is negative, and that's why this reaction is possible in forward direction within the cell. Now here I also want to tell you, so you must be knowing that the value that is K equilibrium. Okay, let's suppose here we are going to denote K equilibrium 1 for this reaction, and you are going to have K equilibrium 2 for the second reaction. Now here if you see, when we calculated overall delta G, what we did, we added both of these values. So here keep in mind, when you are going to calculate the overall net delta G, what you are going to do, you will add both of the delta G value for the two sequential reactions. Okay, for both of these two sequential reaction, what you did, you added. Okay, but if you want to calculate the K equilibrium, okay, for the overall reaction, what you have to do, so let's suppose you are going to calculate the net. Here we are going to represent the K equilibrium 3. It will be K prime equilibrium 1 multiplied by K prime equilibrium 2. Okay, so here for the first reaction is 3.9 into 10 to the power minus 3 per molar. Okay, and then 2 into 10 to the power 5, okay, molar. And if you are going to calculate, it will come out 7.8 into 10 to the power 2. Okay, so here you can see the value of K equilibrium 3 can be calculated if you are going to multiply both. Okay, so here you must keep in mind, when we are going to have two sequential reaction, in that situation you are going to add, okay, for the, if you want to calculate the value of delta G, and if you want to calculate the equilibrium constant, overall equilibrium constant, so you will multiply. So hopefully you have understood the concept of Gibbs free energy. Okay, thank you for watching this. Please do like, share the video, and subscribe to my channel Mahadev Academy of Science. Okay, so this way hopefully we are going to prepare in the best way for DBT JRF exam, then ICMR JRF exam, then your GATE, okay, GATE exam in the area of life science. Okay, and yes, of course, the CSIR UGC net exam, okay, net JRF exam. Okay, so here I am teaching you the fundamentals of biochemistry, and hopefully every point is clear. Thank you for watching this. Have a nice time.